This number 26 is quite difficult. We start with this function f that doesn't really fit any of our models. It's clearly related to an exponential, but it's like the sum of two separate exponentials where a and b are integer constants. And I know whenever a question involves constants, that typically throws off students. And I think in next video, or a future video, we'll see another problem involving constants where the approach is going to be slightly different. Normally, what we would try to do is plug in points in constants questions. And maybe there's a way to do that here, but I want to show you a different way to tackle this one, right? Because we've got g and h, which are equivalent to f. So these are the same thing as f, just rewritten, where k and m are constants. And we want to know which of the following equations displays the y-coordinate of the y-intercept of the graph of this in the xy plane as a constant or coefficient. So looking at these two choices here, these are the constants or coefficients in these equations. So what they're saying here is whatever the y-intercept of this thing is, we should see it in any of these, in one of these values at least. Maybe an a, maybe k, maybe m, maybe 2.2. Like those are all the constants and coefficients of this equation. The variable, which is the x, is the only one we don't really care about here. So the way that I would do it first try is let's find the y-intercept of this guy. We'll leave a and b as a and b. I will show you later we can do this with Desmos by picking a value for a and b, but let's just start with this approach. So let's plug in x equals 0 and find the y-intercept. So it's a times 2.2 to the 0 plus 2.2 to the b. This is a times now 2.2 to the 0. Anything to the 0 is 1. So it's 1 plus 2.2 to the b. So our y-intercept here is a plus a times 2.2 to the b. So this is our y-intercept, right? Again, we don't know the value of a and b here, but this is some y value, 0, comma, a plus a times 2.2 to the b. And now I need to go to the choices and see which of these, if any, have a value that is equivalent to this. Now, at first glance, it doesn't seem like I see anything like this, right? I don't even see a b here, but this is where the k and the m come into play. Maybe, depending on the value we select for k and m, we'd be able to recreate somehow this value as a constant or coefficient in the equation. But again, we literally have to see this. I need to see something like a plus a times 2.2 to the b in the equation. Like maybe it turns out that's what k equals, in which case Roman numeral 1 could work, but we have to do more investigation of these exactly. Remember, they said, starting with Roman numeral 1, that these are equivalent to the original function. So a times 2.2 to the x plus k has got to equal a times 2.2 to the x plus 2.2 to the b. And so with this analysis, what do we see? Well, we know a is just a, so fine. 2.2 to the x matches the 2.2 to the x, right? This is the same as this. And that must mean, in order for these to be equivalent, we know the value of k. The value of k is 2.2 to the b. So I look at all of these constants and coefficients. I look at the a, the 2.2, the k, which we know is just 2.2 to the b. And I ask myself, where do I see this? Do I see this anywhere? Like literally this form? Like, do we see 2.2 to the x plus a times 2.2 to the b? Like, do I see that in here? No, because I know this is just 2.2 to the b. It has to be, given that it's equivalent. So if that's what k is, which of these constants, if any, equal this? The answer is none of them. So Roman numeral 1 is out. How about number 2? We'll do the same process. We're going to set a times 2.2 to the x plus m equal to a times the original function, 2.2 to the x plus 2.2 to the b. Okay, looks pretty close. Let's actually, in our right side, let's just distribute this a so we can really compare apples to apples here. So I get a times 2.2 to the x plus m is equal to a times 2.2 to the x plus a times 2.2 to the b. So now we know that, okay, this equals this. Cool. So that must be the case that m is equal to this. So m is equal to a times 2.2 to the b. And this is so close, right? At least we have this part, right? So m is equal to a times 2.2 to the b. Great. But the value of the y-intercept is a plus a times 2.2 to the b. So we do not actually have here an equivalency. Like this is equal to a times 2.2 to the b, but none of these values, not a, not 2.2, not m, none of these are equal to this y-intercept. And that is why 2 fails and that's why the answer is D. We could also use Desmos here, and what we're going to do is pick a value for A and for B, where A is less than B, and then we're going to plug those values as far as we can into 1 and 2, and then do the same kind of analysis to see are basically K and M the y-intercepts here, because we know the y-intercept is not A. Like we've established that in the previous analysis, and we'll find that again with this analysis. So it really comes down to, again, the question of is either K or M the y-intercept? It also seems unlikely that the 2.2 is. So let's pick an A and a B. I'll just write it like this, and we'll use a slider just to make it clear what we're defining here. So here is our function, and we're going to set A. Let's do A is 3 and B is 4. How about that? Okay. So we actually can find the y-intercept of this. Let me extract this. This is our y-intercept, right? This is our y-intercept of our function. So when we analyze functions g and h, we need to see this number, 73.2768, in the equation somewhere, right? It's got to either be A, we know it's not the 2.2, or M or K. So let's begin with Roman numeral 1. So we're going to do A times, oh, we know A. Yeah, A times 2.2 to the x plus this value K. So now we'll zoom out a little bit. Let's add a slider for K. What we need to do is we need to get this to be equivalent, right? I need this green and this black curve to overlap because they've got to be the same. So I need to pick a K that lets these overlap. Well, I can figure this out based on very similar previous analysis. We know because this equals this, that again, the K has got to equal 2.2 to the B. Like that's just how it's got to work. So can I actually just do that here? Yeah, it does, yeah. So I'm going to say K is equal to 2.2 to the B. And now this equation, you can see the green is overlapping, right? Cool. The black curve and the green curve are the same, so they are equivalent. But now I look, is A equal to 73.2768? No, it's equal to 3. Is 2.2 equal to that? No. Is K equal to that? No, K is 23.4256. That's not 73.2768. So none of these constants or coefficients are equal to the y-intercept of my original function. And so therefore, Roman numeral 1 is out. We can do a similar analysis with, let's turn this one off for a minute. Similar analysis with h of x. So A times 2.2 to the x plus m. So we have to define a value for m at this point, again, to make them equivalent. Looking back on this, we found that it's going to be A times 2.2 to the b. That's going to be, has to be the equivalency here if it's going to work, right? Distributing that a like we did before, right? We distribute that a. This term becomes a times 2.2 to the b. So let's just set this equal to a times 2.2 to the b. Now this is actually pretty close, 70.2768, but it's not quite, right? I needed it to be 73. So when I look at this equation, is a equal to 73 and change? No. Is this equal to that? No. Is m equal to 73 and change? Well, it's equal to 70 and change, but it's not the same. It's got to be equivalent. So again, this proves that it is not 2 either. So the answer is D.